Let us play with the fast-start circuit simulator. Okay, to get it, we are going to go to the course website, to the resources page. Okay, as I mentioned, we have the option to run it online, and that's what I'm going to do right now, or to download it. The download is available here. This gets you directly to the download as a zip file. You just unzip it and then run the jar file, and I'll go through that in a little bit. So let's try this first. When we click on it, okay, it's going to go to the fast-start website, and it opens up in a pop-up window like this. Now it opens up with a default circuit. We can remove that by asking for a blank circuit, and this is our blank slate, and we can do anything we want right now here. Now, one of the things that the simulation provides us with is a lot of pre-made circuits. For example, basics here, Ohm's Law, resistors, capacitors, voltage divider, Thevenin's theorem, that's one of the things we'll try to learn first, etc. AC circuits, passive filters, etc. Let me pull up Ohm's Law. Okay, this is a circuit, for example, that's already pre-made, and it shows us a source here. Notice when I put the cursor over the component color changes, but then also in the bottom here we get a readout based on that component. For example, here it tells us it's a voltage source. I'm sure you don't see it in the video very well, but if you try it yourself, you'll see the same thing. It tells us it's a voltage source. I is 55 milliamps, and the voltage is 5 volts. V is 5 volts. Notice another thing about this simulation. We have different colors. Everything is green here, and then it's grayish here, and the color changes from green to grayish through the resistors. Actually, the color represents the voltage value. Wires at the same color, with the same color, are at the same voltage. That's quite an interesting, useful pedagogical tool. So now here we have only perfect wires on top of the resistors, so we should have the same voltage. Okay, now if I put my cursor over one wire, it tells us it's a one wire, it's 5 milliamps, and the voltage is 5 volts. Same here. Okay, now here it's really part of the resistor, so it tells us what the resistor is. In this particular case, it is 50 milliamps, voltage across it, voltage across the device, or voltage drop across the device. It's called VD, is 5 volts. The resistance is 100 ohms. The current through it is 50 milliamps, and it gives us the power output of that resistor, and in this case is 250 milliwatts. Okay, now this particular simulation gives us the current at these two branches, and this is what we call the ground or the zero voltage value. We'll discuss that later on. Now, one thing we can do, I can right click with the mouse, then it will allow me to change the component. For example, instead of 1 kilo ohm here, I can use the cursor to change it to whatever I want, or I can also type values. Let's say type it 50 here, and apply, press OK, and that changes the circuit. For example, here I have 2 milliamps instead of what I had before. Then when we edit, for example here, that's why it's showing the current, because we are telling it to show the current. We can tell it to show the voltage too. I didn't like that, because it's a wire, there is no voltage drop across it. So it shows the current, it does not show the voltage for a wire, but for something else, like I can go for the resistor and I edit. for the resistor, I see the values here. Okay, now one last thing with this pre-made circuit. Okay, you notice that we can change it, but we can also view the voltage across one component as a scope, like here. So in this particular case, we see the voltage in green as a function of time. And the voltage drop across it is between 5 volts here and 0, so it's 5 volts, so it is a constant green line. Now the yellow line is the current. If I right click here, I can tell it what to show me. For example, I can tell it to remove that, so I see only the voltage, and I can choose other things. Now that's playing with pre-made circuits. So let's have a blank circuit and let's try to build a circuit. You see here, right click the mouse, we can add resistors, wires, input, output. So what I'm going to do is take a classical circuit that you would have used in introductory physics. Let's say a voltage source. I right clicked the mouse, and then now I'm left clicking to add the component. If I keep on left clicking now, it's going to keep on adding components. So I'm going to highlight that component, right click and delete it. I needed only one power source. Delete. And then let's see, let's edit this. I can change the voltage. Okay, if I want it that way. But personally, you see in this particular case, I don't like the fact that it is upside down. So I'm going to redo what I did. I'm still adding a voltage source, and you notice here I have the positive end at the top. I start with a negative and I have the positive end. Now what else do I want to have? I would like to have a resistor probably here, another resistor here, another resistor here. You know, by default all resistors come at 100 ohms, so I'm going to change it, edit, right click and edit. I'm going to make this 1000 ohms. I'm going to keep that 100. I'm going to make this 200. And my voltage source, I'm going to make it 10 volts. Okay, so I need to complete connecting the circuit, so I'm going to add wires. So a wire there, a wire up to here. They can be only straight lines. And then so I have my running circuit right now. So again, like what we talked about before, it tells me here what the resistance value, 100 ohms, the voltage drop across it, 625 millivolts, the current through it, and the power dissipated. Same thing here. So of course we expect a relationship between the current and the current here and the current here. Since it's twice the resistance, we should have half the current, and that's what we get. And the voltage drop is the same since they are both in parallel. Okay, the color resolution is not really that great, so it's difficult to see the difference between the color on top here and the color on the bottom here. But then here we have a voltage level of 625 millivolts, and here we have a voltage level of 0 volts. Now if this resistance here was smaller, we'll have a better resolution because the voltage change is going to be much larger. Let's make this just a 10 ohms, and you'll see now here I have 8.7 volts and here is 0, and you see the color difference, and the whole thing changes. And again, we can have a scope if we want. For example, we are viewing the voltage across this 10 ohm resistor on the scope. The voltage is in green, the current is in yellow, and we can choose what we want to show. Now, this is a simple circuit, but let's assume that we still don't like to go through the pain of redrawing it another time, and we would like to save it. Now, to do that, all what we have to do, we tell it export. Actually, notice you can even export a link that you can send as a link, or you can provide in the homework utility. So export, that gives us this text. So I'm going to copy it, Control C in my case, and then I'm going to go to a text editor. So here is my text editor. I pasted it, and I'm going to save it. It does not matter what you save it as, but I'm going to save it on my desktop as example01 .txt for text. Okay, we're done with that. Now the next thing I'm going to do is illustrate how, oops, here we have a wire that I didn't mean to add, so I'm going to delete it. Right click, I remove add wire. So again, made the same error, delete. Okay, I tried to remove add wire, but actually I need to say select drag here. Once I do that, now I can drag and select part of the circuit. I can go here, for example, and say copy. I can go here and say paste. And for example, I have these two circuits. I would like to compare the effect of that resistance. I'll make it 100 ohms. So we have the two circuits here, and we can compare what's happening to both of them. So if I would like to view this one in scope, so I can view it here. So this one is here. This one actually, okay, it seems we have the same one. So I'm going to remove it, and I'm going to view this one. Okay, you see when I highlight it, the bottom scope takes the same color. Same here. And that's, I'm comparing two circuits. I can try different things, I can read the different values, etc. Now, what about if I would like to run a circuit that I have already saved? So all what I have to do, I have to go to import, and you see there it's empty. So I can go to my text editor, copy, and paste, import. So it brings us back to the same circuit that we had before. Okay, of course you can stop a circuit from running. One last thing, these small dots that move are supposed to be positive charges that are moving through the circuit. Of course, we don't have positive charges, but it's a way to illustrate the current in the circuit as the simulation progresses. Go to our resources website. I'm going to download the zip. So I'm going to save the file. So I'm going to move it to my desktop and zip it. I use the freeware 7-zip, so I'm going to extract it to the circuit folder. Go back to the desktop. Okay, actually let's go there. So here is the circuit folder, and you notice that there is a jar file, and that's our jar file, and you can run it the same way. Of course, if you are using a Macintosh, the look will be slightly different, but it should run the same way, and you should have the same menu items. One last thing, when you tell it export link, it's going to give you a link. I copy it. Okay, so I'm going to go to my Firefox. I come here, paste that link, and it's going to pull out for me the same circuit.